In this question it says, for the reaction below at a certain temperature, the reaction vessel has a total pressure of 2 atmospheres. If the reaction started with only HI and the mole fraction of H2 at equilibrium is 0.18, what is the value of Kp? Well, let's start by writing the Kp expression. So Kp equals products over reactants, but they're in pressure instead of concentration units. Since they're all gases, they're all included. So in this case, the first product is the pressure of hydrogen times the pressure of iodine divided by the pressure of HI squared. Why squared? Because there's two HIs. Well, this is great, except that it doesn't look like we have any of the pressures of these things. So we have to remember back to our gas law chapter. And our gas law chapter tells us, using Dalton's law of partial pressures, that the pressure of hydrogen is equal to the pressure total times the mole fraction of hydrogen. So the pressure of hydrogen is the total pressure, 2.0 atmospheres, times the mole fraction of hydrogen at equilibrium, which is 0.18, which means that the pressure of hydrogen is 0.36 atmospheres. Now, there's a very interesting detail here that seems small that we really have to pay attention to. It says the reaction started with only HI, which means we didn't add any hydrogen or iodine. So every time an HI decomposes, or every time two HI decomposes, you get one hydrogen and one iodine. Said another way, if the pressure of hydrogen is 0.36 atmospheres, the pressure of iodine is also 0.36 atmospheres. Now we're only left to find the pressure of HI. Well, this we can do because we know the total pressure. So the total pressure is 2 atmospheres. So whatever's left, whatever isn't hydrogen and iodine, must be HI because it's the only other thing in the vessel. So how do we find that out? Well, we take 2 atmospheres, this is the pressure of HI, equals 2 atmospheres minus 0.36 atmospheres for the hydrogen minus another 0.36 atmospheres for the iodine. So we take the total pressure, we subtract the hydrogen, we subtract the iodine, and what we find is that the pressure of the HI is 1.28 atmospheres. Well, now we can just simply plug in. Kp equals 0.36 times 0.36 divided by 1.28 squared. And you don't necessarily need to put the parentheses there. When you do that math, you get Kp equals 0.077. So this is how we can use Dalton's law of partial pressures and some information to actually determine the Kp value.